right? Hey, thanks everyone for joining another wonderful session. And my name is Adam. Now, most of the time, whenever you are working as a DevOps or SRE engineer, you'll be doing some activities, but we consider it as a project. But unfortunately, whenever we say project, we just talk about one or two tools and we just speak about a small task that we have done in that. But in reality, when you are going to an interview or to a client, if you have to talk about a project, it covers various aspects and it's like preparing a full course meal, okay? Not to just talk about a single food. So in that way, this session is completely focused about giving you a real-time experience on how does an actual project look like when you go to a large tech giant organizations, right? And what are the expectations that they would have so that if you want to answer any questions related, okay, can you explain your project or what is that you have recently done? You need to know those. Okay. So pretty much I'll be focusing on various aspects in terms of how do we design and how do we use different tools, as well as in the end, I'll make sure how do you take this and put it in your resume or how you should be explaining in an interview. So that way, make sure you take notes as much as possible. All right. And if you have any questions, as I said, at this time of recording, please put it in chat or I'll take up the questions at the end of the session. Right. So I want you to remember 6 points anytime when we say a project. Okay. So regardless of whatever interviews that you're going through, especially on the DevOps or SRE, whether you are creating a small machine or a database, or you are running some application, the 6 points that you need to know is whatever the solution that you are trying to give, it should be designed in such a way it works only on cloud, or it has to be working on a cloud native, whether it could be AWS or it could be Azure or it could be GCP or it could be a combination, doesn't matter. So that way your solution that you're designing should be a cloud native solution specifically for cloud. Then the solution, whatever you are working, should be having a high availability. What is high availability in a short way? So let's assume you're accessing a application or a database. Creating that is not a project. What will happen if it goes down? How quickly can you create another copy of the application or another copy of the database and make sure that the user doesn't get impacted? So that's what is called as high availability. Then disaster recovery. Again, in a simple words, what is disaster recovery? You might have all heard about the recent outage in AWS, right? Well, we don't have to worry about what happened and what did AWS fixed, but if a outage happens on AWS, it's going to be an impact for the business. So if your company is using AWS and running some applications and customers are using it, and if an outage happens in AWS, how are you going to make sure that the impact is not on the customers? So that is where you need to make sure in such a way that even when an entire region in AWS, like a Mumbai region or US East region is not working, can you bring your application in another region, which is what we call it as disaster recovery. So no matter what you are trying to give a solution, you should also think about having a disaster recovery. And then the solution should also have the monitoring and observability, which will help you to look at what is happening. If there is a problem, For example, it could be a resource issue like a hard disk or a CPU or a RAM, or even it could be some kind of network issue, or it could be a performance issue. So monitoring and observability is another best practice which you need to consider while designing your solution. However, most of the solution what you are going to work will be cloud native. So because of it, it also has to be secure. So which is where whatever that you are doing, you should also consider security in it. So which is what we call it as the DevSecOps. So how are you running? How are users going to access? So what is the security that you're going to bring in place? And security is not something which you are going to only consider while running the application or running the database or whatever the machine, but you need to consider a shift left approach. What is shift left? Your security has to be into the consideration right from the design and development of whatever the solution you're giving. So that is what companies are looking at as DevOps or DevSecOps. And finally comes the automation. Okay. So now whatever that you have designed, what are the different tools that you are going to use, different techniques that you are going to use to get the solution. So which is when it might be more than one tools that you want to use. So typically when we say a project, you need to talk about all these things on what are the different tools you have used. Okay, what are the different processes you have used? What is the design that you have done completely on cloud? And it should also have high availability, disaster recovery, monitoring, as well as security right from the beginning. So this way, I'm going to split this into two sessions. And in the first session, what we will do, we will focus more about understanding the high availability, right? And also the design perspective, as well as the security. And then we'll look into the automation. And for that, what tools that we need. And on the second session, we'll talk more about, again, the remaining half of the security, the disaster recovery, and also something on the monitoring side. All right. Now, before we take an example or a live example and look at it, I also want you to know whenever you say a project is not just about operations. Again, this is the mistake which most of us do. Whenever we ask to explain a candidate on what is the recent project you worked, you will always talk only about implementing it. That means someone has developed and given, and you are just running. But whereas whenever we say a project, right, it also has a life cycle in which you need to talk right from the beginning where how did you design on the solution, which is, as I said, cloud native, as well as it has a high availability and disaster recovery, and what are the other best practices needed for automation, and then you develop it. Once again, whenever we say develop, you don't have to just sit and waste time in writing code, but use the help of AI or AI based tools to generate your code in a faster way. And that is when exactly what are the different tools, and for that, what code that you might to develop, like Terraform code or Ansible code, or let's say Kubernetes code, or even if you want to write a small shell script, what is that you're going to do? Now, only after you develop, you will have to implement. And this is where implementing is about, okay, you designed all these and you developed, let's say, a Terraform code or an Ansible code or a Kubernetes code. Now, you have to execute them in any of your cloud environment, right? So that's where you have to talk right from design to developing and implementing. And finally, once the implementation is completed, you will then start monitoring it. So your monitoring and observability will come around this. And not only that, there is also a part of DevSecOps, which I'll explain you. But in general, in the modern way, you're not just going to say that I have designed, developed, implement, and operate. There is a life cycle for which in most of the product based companies, they use these terms called day zero, day one, and day two. Okay. So typically day zero means for a particular problem or a solution, you have designed and you are ready for the development. Again, what developing? Developing the automation. And once you have completed your development, and if you're ready to implement and run that in a real environment, then we call it as day one. And after implementing it, let's say on your production, and you want to start monitoring it and observing it, then we call it as day two operations. So remember, the projects that you explain should cover what you did on day zero, day one, and day two. So that is how you can easily talk about any problem that you took 1 month or 2 months or 6 months to achieve. So that's when project is not just about talking only on the operations or only on the implementation side. Okay. Again, the idea for this session is to help you understand how this will work. Now, let me take up an example on how do we achieve all these things which we are talking about, right? Now, for this, let's assume you join an organization and there is multiple products that they run, right? Let's assume that there are some 10 to 15 products that your client is working or the business unit that you've been associated are working. Now, in that, one of the common activities that we will be doing is you need to run CI/CD pipelines, or you might have to run a couple of other deployment pipelines for the product release. Now, the release can happen once in a month, once in 2 months, or 3 months. Now, regardless of that, what is that you need? Now, let's say in your company, in order to manage the CI/CD pipelines and releases, you need a tool which will help you to automate these pipelines or the CI/CD jobs. And that's where, again, one of the popular tool people might be using is Jenkins. So the requirement that I have, which is a real-time scenario, is I want you to set up a Jenkins as an application by considering all those 6 best practices. Now that is where as soon as I say Jenkins, people will be like having a small smile. Oh, what is big deal? I will just take 2 machines, I will install Jenkins and I will run. Well, if you are telling it, that's the old method of saying. Whereas if the same question, if it comes to you, go and join a very large product company like Netflix, Uber, Oracle, right? Amazon, whatever it is. Do you think they will just run it? So what is that you did for giving a cloud-based design or a cloud-native design? High availability, disaster recovery, what is the observability and monitoring you did? What is the security you did? And what's the overall automation and different tools that you have used? So this is where I want to pick up this example, which is one of the thing which we did for a client, and it's also easy for you to compare. Now, do not think that whatever we are talking or going to talk is only for Jenkins. You can replace Jenkins with any application, any tool that you want. So the process remains the same. Okay, so let's get started. Now, as I said, my requirement is I want you to run Jenkins so that the developers or QA or anyone from the operations or in the production can use Jenkins. But one of the best practice that I told you is I need to make sure Jenkins is highly available, especially let's say if I'm running it in production. So what is high availability for Jenkins? So if you're running Jenkins on one machine, what happens if the machine crashes? So I need to make sure I have another machine in which I can run the Jenkins immediately. So as a user, we should not be worried about it. So what is that I can do whenever a machine in which Jenkins is running is failed or it is crashed? How quickly can I bring up another machine in which Jenkins can run? Now, along with that, it is not sufficient if I just bring the Jenkins. So let's assume I'll have 2 machines. If one machine goes down, I can ask Jenkins to run on another machine and it will run. But in Jenkins, we know that we create a lot of jobs, correct? And plugins. Now, it is not just about bringing another machine and running Jenkins, but how do you make sure that the jobs and the data whatever that you had on the first Jenkins, it is also available on the new machine. Because whatever you do in Jenkins, it stores in a folder called where lib Jenkins that will be inside a specific machine. So if you take a new machine, how do you make sure the same data is also coming on the second machine? So high availability is not just about if one machine goes down, how do you bring another machine, but how do you make sure the data from the previous machine is also available on the new machine? Okay. Now, along with it, you also need to think about something called as load balancing. What is load balancing? Now, as a user or a customer, let's say you just type facebook.com, linkedin.com, google.com. You don't care whether it is going to a specific machine, right? The same way, if users want to access Jenkins, you should not be telling them the IP address of the machine 1 or machine 2 because they should not be bothered about machine 1 or machine 2. Simply, you are going to give them a load balancer or an address of a load balancer, and the load balancer should decide out of two machines which machine is properly working, and that is what user should access. So the moment a machine fails, you should automatically create another machine, make sure the data is also replicated, and the same time as a user when you're trying to access, it should also go to the new machine. So that is where high availability, especially for a tool like Jenkins, requires these three factors to be considered. So how do you get this? And this is where I want to achieve this on a cloud native solution. Now, for my example, I'm going to take AWS as my cloud. Now, you can compare the same way for any of the cloud. It's almost the same. So, how do I design my Jenkins high availability on AWS, which will have these features? So, this is where you need to start looking at what are the services in AWS that you are going to use to achieve it. Okay, so start making notes one by one. Now, as soon as we say AWS, right? Now let's consider for a minute, there is a separate network, which is VPC, and you also have some of the components of your AWS network for you to run the application. Now, which is where in AWS, you are going to pick a particular region. Now, again, assume I am going to take AWS and Mumbai region in it. And in Mumbai region, I'm going to have a separate network. And in this network, let's also assume I have two separate subnets because high availability inside a particular region means if you are running a machine in one subnet in a particular availability zone means a particular building in Mumbai region. So for any reason, if let's say the machine in this availability zone crashes, you should be automatically able to recreate another machine in a different availability zone in the same region. So which is where which service gives you the ability to recreate the machine automatically if it goes down. And for that, we are going to use a service called auto scaling. Okay. Now, we also call it as ASG, auto scaling group. Now, what we can do is you can create a service called auto scaling group and you can tell how many machines you want to be running in it. For example, if you say one machine, the auto scaling group will make sure always there is one machine running for which you can tell what are the subnets inside which it has to run. The same way, if you say two machines, the AWS auto scaling group will make sure two machines are always running. But if a machine goes down, an auto scaling group has to create a new machine which will replace the existing machine. How does it know what is the machine it has to create, right? See, it's like I am asking you, can you please go to AWS and create a machine in Mumbai region? Then you will ask me the question, okay, tell me what should be the image that I take, which is called as AMI, right? And then you will say, what should be the type of the machine? That is the capacity that you want to take, the CPU and the RAM. hard disk, and then you will also say, okay, tell me what should be the security group that you want to add or in which network it has to be. And other than that, you might also ask, do you have any requirement to say a specific PEM file or a password that you want to give, right? So like that, there are some questions that you have to answer. The same way, how does auto scaling group know which machine to recreate? Because it has to exactly recreate the same machine. So for that, we will actually use something called as a template or a launch template. So for an auto scaling group service in AWS, there is inbuilt another service called launch template. So in this template, we will tell what is the machine that you need, what OS or AMI that you need, what should be the type and resource of the machine, in which network you have to create, what should be the PEM file associated, right? So all those information you give it. So this is whenever now, if I create an auto scaling group and if I tell take a particular AMI in which I can run my application. And like I said, you can have one machine or two machines. Now, what will happen is the auto scaling group will make sure that how many machines that you want will always be running. By any chance, if any of the machine goes down, the auto scaling group will use the same template and it will try to recreate. So this is how any point of time you will always have a machine available for you. Okay, so this solves the first problem. But the second problem that I was saying in high ability is, okay, so let's say you had a machine. Now, if this machine goes down, then auto scaling group will recreate another machine, let's say on the second availability zone. So as a user, you got the new machine and the application is running. But how do you make sure the data that you had on the machine one will be shared to machine two? That is, if you are running Jenkins on machine one and the where lib Jenkins is specific to that machine. So when you create a new machine, there won't be any where lib Jenkins. So how do you make sure the data from machine one comes to machine two? So for sharing the data or duplicating the data, we need to use a storage like EFS. Okay, because in this scenario, we are talking about sharing a file system between two machines. So for this, the best solution that I would recommend is to use a storage as EFS. So in that case, for this solution, along with the auto scaling group, you also need to make sure you have a storage like EFS, which is mounted. So anytime using this template, when you create a new machine, the EFS should be automatically mounted in it. So that's how, if one machine goes down, the same data will be available in any other machine that the auto scaling group creates. So your second problem is also solved in high ability. But what is the third one? Now, as a user, which one that they should access, and which is where you should start using a load balancer. So for this, you have another service in AWS called Elastic Load Balancer. Now again, you can create a classic load balancer or application load balancer, and you tie it up to the auto scaling group. So this way, as a user, rather than accessing the machine, the user should access the load balancer's ID. The load balancer will redirect to whichever machine is working fine. So that's how, assume there is machine one or server one. This is what user will be accessing. Suddenly, if this machine crashes, auto scaling group will take the template and it will recreate another machine, server two, and the data from the machine one will come to machine two. The moment it comes, then the user tries to access the load balancer, it will redirect it to the machine two. So that is where you will be able to achieve all the three things that I just told you for high ability using this architecture. And this is completely cloud native. Now, this looks perfect, and this is where your solution doesn't stop. Why? Okay. Now, what did I say? You go to AWS and you design it using a launch template and a auto scaling group. Fine. But let me ask you another question. In AWS, when you define a launch template, you will say which AMI that you have to take. AMI means the image. So the AMI will be based out of Ubuntu or CentOS or Fedora, right, or Red Hat. But that AMI will not have the application like Jenkins. So typically, what you have to do now is, if I just take, for example, Ubuntu or Red Hat AMI, then when a machine goes down, autoscaling group will only create the machine. But how do you make sure inside the machine you have the specific version of Java or specific version of Jenkins that is needed for you? So that is where creating a machine is one work, but making sure that you have the right version of Java and Jenkins installed in it is another work. Now, how do you achieve? Now, this is where most of you might tell, okay, I can create the machine, and after creating the machine, I can run some tool or some automation to install, which is good. But in a real time, let's say something like in production, creating the machine will take couple of seconds to 1 or 2 minutes. And top of that, if you're going to install some application like Jenkins, will it not be taking time? So even if you are going to spend 10 minutes, 10 minutes is where users are not accessing your solution. So, which is not acceptable. So how can you reduce it? That is one point. And second, is it really secure? How do you secure this machine and application? So this is where in most of the organization, we do not just take the AMIs that is given by cloud or which is a public image. So instead, what we also have to do is generate our own image. So that's where let's first understand all the design and then we will see how to implement it. Okay. Now, in companies, we call it as a golden image. Okay. Now, these are all terminologies that you should know in real time. So what is golden image? Instead of taking the direct AWS or public images, you are going to create your own image as required in the organization by putting up whatever the right version of applications that you want and secure it, and then build your own image out of it, which is what we call it as golden image. Okay. So instead of taking it directly, you take it and add whatever the configurations that you want, however you want to secure it, and then we go ahead and create our own AMI, which is certified within the company. So which is what we generally call it as golden AMI. Okay. Now, how do you create a AMI in AWS? Now, you can take a AMI, which is the base AMI, create a temporary machine, go inside the machine, and then install whatever that you want, and then convert that machine into an image. Now, this is a regular process, but we are not looking at doing this manually. Why? Because you might have to create this image multiple times. So I will tell you the reason for that also. Okay. So for now, just think this. If it is a one time, I don't have to do. But if I ask you to frequently create this AMI, then how are you going to automate it? So that's when you should also now think about automating it. So see, before you go and implement the previous solution, that is the high availability architecture using auto scaling group, EFS, and load balancer, you also have to first think about creating your own golden image. Now, for this, one of the popular tool that I would like to prefer is Terraform for infrastructure, but for building the AMI, there is a tool called HashiCorp Packer. Okay, so Packer is specialized for building or creating AMIs. AMIs means your image automatically. Now, what will this do? It will exactly do the automation like how we did manually. So when you run Packer, you can tell what is the base image that you want to take, and Packer will create a temporary machine. Then you tell what you want to run inside it and configure. So like Terraform, there is also a concept called provisioner, in which once this temporary machine is created, we can go inside and we can run whatever the configurations that we want to do. Now, this is where running Packer is for the overall process. But the moment when I say you want to configure the machine, what do you mean by configure the machine? Well, you want to install some commands like Java or a specific version of Java or some other libraries, and then specific version of Jenkins. You might have to download some key. Then how do you automate it? And why are you thinking about automating it? This is because, see, today you might be having one version of Jenkins. After some time, there might be another version of Jenkins. Same way, today you might be using, let's say, JDK 8, and then there might be JDK 21. So Java is also changing. So every time when I am changing any of the configuration, whether it is for Java or for OS or for Jenkins, I don't want to sit and manually do it. And which is where for machine or server configurations automating, we will use another tool, which is Ansible. Okay, so now we will try to develop some automation in Ansible. So basically we call it as playbooks or role, and you design your Ansible playbook in such a way it can install whatever the specific version of the OS or Java or Jenkins. So this way, if you change some variables or parameters in Ansible, Ansible will automatically download, right? See, that is what is the beauty that you're doing in automation. I don't want to always install, let's say, JDK 11. Now, the same playbook of Ansible, I will just change or pass the variable and say, hey, instead of installing JDK 11, please install JDK 21. So it'll go ahead and do that. Same thing is Jenkins. So that is how, for automating the server configuration, you can use Ansible. So how does it work? So you call Packer. So Packer will create a temporary machine based out of a base OS that you tell. And with the help of Packer, we will call Ansible and we will install and configure whatever the versions and the application that you want. And once Ansible has completed, then Packer will convert this temporary machine into a golden AMI, so which is certified from your organization. So this is how, if you automate this process of Packer, whenever I want and whatever the versions of the packages that I want, I can specify and Packer can build a new AMI for us. Okay. Now, this is just about automating. But this is where I also told you, you need to think of security as an approach right from the beginning. So how do I bring in security here or DevSecOps? For me, it is not just building this AMI, because you took the AMI, which is the base AMI of Ubuntu, then you downloaded the Java and Jenkins again from some public place. Is it really secure? How do you know whether this AMI is secure or not? Because it is not that I will take this AMI, run the machine, and then in the machine, if there is some vulnerability, I will try to fix. But while you are developing or building this, you need to fix. So which is where we need to make sure anytime when you build your AMI, you are also going to scan. Exactly like when I say your build pipeline, right? You will apply a scanning where if you're creating your own Docker image, you make sure that there is no vulnerabilities and then give it to QA or production to run. Similar to that, before you are going to use this AMI and run it in production, you need to make sure that you scan it and find out if there is a vulnerability. And suppose if there is a vulnerability, then go back to the same process and you fix it. So that is where Ansible is not just used to simply install whatever versions of Java or Jenkins, but using your Ansible, you can also keep updating the fixes or the vulnerabilities what you're going to do. Okay, I'm going to talk specifically about it a little later. Okay, but for now, just understand you're not just blindly building, but after you build it, you also scan, and which is where for automating the scan, you can think of using some tool like Trivi. Okay, so now there is running Packer, and Packer will run Ansible and configure and create a machine, and then you are going to scan. So which is where you can automate this also entirely. See, this is separate automation, this is separate automation. But how do I run this together? So which is when you can think of having a pipeline. Okay, so what is pipeline? Now you put all the code that you want for the Packer, for Ansible, and for your Trivi in a common repo like a Git repo, and you can run it. Now for that, you can use another Jenkins, or you can use GitLab or GitHub, doesn't matter. The idea is how do I automate it as a pipeline? And in that pipeline, you just define the stages. So here I'm just giving you the idea on how you should do. So first, let's assume that I'm going to have a pipeline in which I go to a particular machine in which I want to run all these. In that machine, as a first stage, I will check out and try to get all the specific files that I need. And then in the stage two, we will call Packer, and in the Packer, it will try to create a temporary machine, and then it will call Ansible, and then it will convert it into a AMI. And once it is done, in your pipeline, the stage three should be scanning your AMI and finding out whether there are vulnerabilities or not. So this way, the solution that you're giving is not just using a tool like Packer, Ansible, or Trivi, or you can also write some small shell script to help you, but eventually to run this entirely as a pipeline. And this is where you can use different set of tools for it. Now, preferably what I will do, I will try to run this as a Jenkins based pipeline, and also to call different stages, I will use Terraform. Okay, so Terraform is to trigger this, whereas Packer is to actually create the AMI, and Ansible is to configure that AMI, and Trivi is to scan them. Okay, and now the next question that comes, which you need to know: why did I even created a pipeline? How frequently should I run? There is a reason for everything. Now, if you go back, once I generate the golden image, and which is what we are going to use to create a high available architecture, and you can run your Jenkins, but very frequently Jenkins will be upgraded. So Jenkins gets upgraded once in 12 weeks. So what you have to do is, if you are setting up such an architecture in your company, once in 3 months, you need to build a new AMI, which will consider having the latest version of Jenkins. Now, an example I'm just saying, let's say today you have Jenkins 1.26. So you run this and you generate a new AMI in which you will be having a specific version of Java and Jenkins 1.26. Now, after 3 months, Jenkins updates a new release, let's say 1.28. Then you're going to simply run the pipeline, and this pipeline should build you a new golden image in which you have Jenkins 1.28. So that is where this is not a one-time effort, but any point of time, based on how frequently Jenkins is going to release, you are going to make sure that we are going to have a new AMI available. So stick to this, because you need it for your second session also. So for now, what we are looking at is how do you provide a solution in which you are going to have a pipeline for your Jenkins golden image, which is also secure, and you can run it once in 3 months. All right. Now, assume you have completed it. Then I will just go back to this and you can compare. So this is where now when you try to create a launch template in your auto scaling group, you are going to give the golden AMI which you built in your organization and which version of Jenkins. So every 3 months you are going to build. So within your company, if someone comes or in the product, whether it's a developer, QA, or someone in production, they say that, hey, Adam, I want to create a Jenkins for my application for production, and I need a Jenkins of version 1.26. Then all you will tell is there is a specific golden image, please use it. So they are going to create their own launch template, auto scaling group, and load balancer and EFS. And in that, in the launch template, they will give the AMI of 1.26 Jenkins. Now, same another person comes like Adam, I want Jenkins 1.28. Then the same architecture, you are going to tell them to use the template of AMI in which you have Jenkins 1.28. So what is important now is you keep building your AMIs once in 3 months, and whenever you need to actually implement and create a Jenkins running for your production, you need to make sure the right AMI has to be generated. Okay. Now let me show more into practicals. Okay. Now for this, first of all, let me try to start some machines and I'll explain you how do we automate. So this is what we have just designed, and we have set up an architecture which is a cloud native solution. Now, what I wanted to show you also is, so assume you have started building the images, then how does it look? So what we are going to achieve is, we are going to achieve building this AMI, and then we will set up a Jenkins, assume for one of the product you want to do. So this is where every time when you run a pipeline, you are going to build a separate AMI, okay, which is going to look something like this. So for this example, I'm just saying I built one AMI on May, and then I built one AMI on 25. Now I need to build a pipeline from the scratch where if I run it, it is going to build a new AMI for me on November with the latest version of Jenkins. So that's what is our idea. So what are the tools that we are going to use? Now this is where you have to think about automation. Okay. Now what and all automation that we want to do? So first we need to have Packer for building AMI again. So you're going to develop code related to it. Then you're going to have Ansible for configuring or configuring Jenkins master as well as some OS updates. Okay. Then you need Trivy for scanning vulnerabilities. See, I'm just telling you how you should think of automating. That is where different tools will come. And then in AWS, what and all you have to do. Now, this is where if you are going to set up this architecture, then you need to use Terraform because it uses the infra as code for creating all of them. So pretty much we are going to use Terraform for infra creation, whatever it is. So what is the infrastructure? Now, you can set up a network which can include VPC, subnet, internet gateway, route table, security group, all of that. Then you also need to create auto scaling group or template, and you're going to create EFS, you're going to create the load balancer, right? So all these things you're going to do using Terraform. And I will also use a little bit of shell script, okay, to automate certain processes, which I will show you. And eventually, I'm also going to use Jenkins pipeline for automating the AMI builds. So which is where now you see, in order for me to achieve these two solution, these are the various tools that I'm going to take. Okay. And let's get started. So first, what we will do now, this is where I have three machines with me. So I have a Terraform machine and I have a machine in which I have my Jenkins and slave running. So what I will do, in order for us to first execute this pipeline, you need to have a slave machine. And in this slave machine, I need to make sure all the necessary tools are there. So what are those tools? I need to make sure Terraform is there. I need to make sure Packer is there. I need to make sure Ansible is there. And I need to make sure Trivy is there. Okay. So this is where what I will do. Typically, it takes around 15 minutes for us to run this pipeline. So let me first quickly set it up and run, and then I'll explain you each and everything on how exactly it is done, and I'll give you a walkthrough on the code so that you will get familiarity. So what we will do, I'll go back, and this is where I have two sets of repo. Okay, now everything is developed, and assuming I have already developed it, so we are just focusing on the implementation. So there is a repo in which I have my Terraform code, and there is a repo in which I have my code for Packer, Ansible, and a little shell scripts to help me to automate this pipeline, as well as I also have a Jenkins file for my pipeline. Okay, so that's how I put all of that. So typically I want to run this pipeline, and I'll show you what I'm doing in this pipeline. So in this pipeline, I'm going to run it against a machine called Packer, in which I have everything installed, so which is going to act as my slave machine. And we are going to set up the credential because Packer also has to connect to AWS, the same region and the same credentials. So we are going to pass the credentials from Jenkins to Packer. So that is where I'm giving this as an environment variable. And here you can see I'm trying to call Terraform. And what does Terraform will do? Terraform will internally call Packer. And then Packer will do all the activity and Packer will call Ansible. So which I'll show you in the workflow. And then we are just simply going to scan the newly built image that we have from the Packer. So this is how, whenever I run this pipeline, you're going to have this three stages. You check out all the code, you build the AMI by configuring specifically. So now I have written the Ansible in such a way that it'll always take the latest Jenkins and specific version of Java, and we will also do the scanning. But there is one more thing important that you need to know. Now, since the AMI, whatever that we are going to create here, will be used for this solution, you need to make sure that the EFS that we are going to use is available or mounted in the AMI. So what do you mean by that is you need to make sure EFS is already created and you mount that when you do a configuration. Now, because of the space, I didn't write. So what will Ansible do now? It will not just install Java and Jenkins, but it will also mount the EFS. So this is how in this AMI, there is one EFS that you're going to refer. So with the help of it, how many ever machines that you create, it will be mounting the same EFS. So that is where for each product, suppose if you want to make sure you are going to have a separate Jenkins, then make sure while you are building the AMI, you have a separate EFS that you are mapped. So which is where in the workflow, before I run this pipeline, I need to make sure that I have a EFS created. So then goes back to the question. So what would be my process? So my first step is to create EFS. Okay. And then I will have to run the pipeline. So once again, now where is EFS coming? EFS comes into the infrastructure, which is the IAC. So it doesn't matter whatever you do in cloud, you should use the IAC, and IAC means Terraform. So what we have to do now is you need to develop a Terraform code or a module which will help you to create EFS. And that's what I have it in another project. So this is another Git project in which I have modules. See, this is what I was talking about, my development part. Now, here I have the EFS, and whenever I call it, this will create a new EFS for me. Now, this is when you need to first make sure, in order for you to create the EFS, in which network you want to create, right? Because every time there is going to be a separate network. Now, for the sake of preparing first, you can create it on a default network. If not, first you should create a network and then come to creating all the other things. For a minute, let's say you have already created, because you still don't know from a security point what and all is needed in AWS network, right? So that is what I will try to talk about this in the session 2. But for now, assume I'm going to take the default VPC or network and the default security group, and we will do all these things. Now, exactly, find out what is your default VPC and what are the subnets that you want in which the machine should run, and the EFS, because it is again related to this. Okay, so your EFS is going to be mounted on the machine, and where are this machine running? In some specific subnet. So when you're creating the auto scaling group, you need to make sure which VPC, which subnet in which it will run. And accordingly, your EFS will also run on the same subnet. And that is what I'm just trying to give. Now, to show you this, let me go to my VPC, and I'll try to take my default VPC and we'll work. So you can replace it accordingly to your account. Okay, so this is my VPC. Okay, so here, that's the same VPC, and I have subnets here. So these are the three subnets: 248, 5F1, OCE6, and that's what you have. So you can just update. So this way, the EFS that I'm creating is for a specific project. Okay. So let's assume that I'm supporting a particular product, and for that they need it. So I'm going to put their VPC and the subnets that I have it. And the EFS that I'm going to create, I'm just giving the name as JRP. JRP means a job ready program. So you're making this as a job ready for yourself. All right. And we will create the EFS and make sure it is available in all the subnets inside the VPC. So now I have to execute the Terraform. And this is exactly where, let me go to my Terraform machine. Now I've already downloaded this code. You just have to do a git clone and get it. Okay. And this is the same code what we are seeing here. This is the same code. Now here, let's go to EFS. All right. And you will execute your Terraform workflow. Again, it's a one-time activity. So you have to start with Terraform init. Again, for those who want to know what is the best practice in running Terraform in a production, I have a separate video that's already put into the channel. Please go through so that you will try to learn when running Terraform in production, what are the considerations you're going to have, right? Because here the focus is not just Terraform overall, and because of the time constraint, I'm not keeping certain things. For example, when you run Terraform, you need to have a specific remote state file or a remote backend, state lock, all those things. So that's something which I'm not showing here, but please refer to it so that you will get to know. All right, now you can just do a plan. All right, let's go ahead and Terraform apply. So you can see we are creating a new file system for EFS, and it is going to be on this subnet. Now what we can also do, go back to AWS, and I'll just search for EFS. You should be seeing that there is a new EFS file system that has been created. This is almost complete. Now, when we build our AMI through our Ansible, we should tell to mount this automatically. Okay, so that's how I've already developed the Ansible code, or you should be thinking of developing your Ansible code in such a way it takes whichever the image that you want. So that is why use Ansible so that you can configure. Now, suppose assume there are two separate project or product or two different client, then you create two separate EFS. And when you are running Ansible in the same pipeline, you can tell which ID of the EFS that you want to take, and accordingly, it will try to generate the AMI. Okay, so this is complete. So perfect. So now we have the EFS. So all we have to do is now execute this pipeline, wherein you have Packer and you have Trivy, Terraform, and Ansible all on this in the slave machine. So which is where I'll quickly again go back and I'll now show you. So I'm using Jenkins once again for running this as a pipeline, and this is my slave machine. Now let's open a new command prompt. Okay, so what and all I need? See, obviously you need Java to run everything for Jenkins. So you have Java, you have Terraform in this machine. Do you have Packer in this machine? Do you have Trivy in this machine? And Ansible, I'm not going to run from this machine. Instead, we will run Ansible directly inside this machine. Okay, and I'll tell you the reason why I'm doing it when I go through the code. So that way, you have almost everything that is needed for you. But typically, this is where when the first time when you're creating the machine, how do you just install all of them? So that's where if you come back to this project code, right? So I have a bunch of files. Now I have a file here which says two shell script, setup.sh and install.sh. So pretty much, let's say I use this install.sh. So this will be installing me the right version of Terraform, the AWS CLI that I need. Yeah, I forgot that also. Why do you need it? Because when you're trying to scan through Trivy, how do you know what is the latest AMI that you have built? So I don't want to hard code anything. So that is where we will use AWS CLI and we will try to read the latest AMI that you have built. So that's where I'm installing, and you're installing Packer, and you're also installing Trivy and the specific version of Java or JRE that you need. So that's how whatever specific version that we need, we are going to make sure, and also AWS CLI is available. Okay, so we have everything that we need in the machine. And coming back, now I don't have to do anything going to this machine directly, but let's go to this Jenkins master. So this is mainly for the pipeline. As I said, you replace this with your GitLab or GitHub, anything that you like. But since I just have everything over here on Jenkins, I'm just trying to show you. So I'm going to use this Jenkins to execute the pipeline, wherein whenever I want, I can run this pipeline, and it should be building me a new AMI. So again, to save time, what I have already done in this Jenkins, I have already added this slave machine. Okay. So all we have to do is set up the job and start running. So two things we need to know is you need to make sure that the right slave is added and you have all the tools installed on the slave machine. And second thing, for the pipeline to run, you need to have